we're now going to turn our attention to something called sigma notation. Sums can be represented with sigma notation. The word sigma is the pronunciation for the Greek letter S and is written as this symbol here. It is also used within the notation itself. Sigma notation states that the sum of n terms, n means any number, and those terms can be a1, a2, a3, up to a sub n, is written as the notation you see below. Now let's dissect what this means. So I is the index of summation. That's the value to substitute into the formula. So whatever I is here, we're going to start with 1 and we substitute that into the formula. A sub I is a particular term within the sum. So if it's a sub 1, that's the first term in the sum. A sub 2 is the second term in the sum. A sub 3 is the third term in the sum, and so on. N is the upper bound. That's the highest or the last value that you would be adding up to, the last value for I. And 1 is the lower bound. That's the initial or first value for the letter I. Example number 1 is sigma notation. Let's find the sum of I squared going from 1 to 4. So we substitute 1 through 4 into I squared and add those together. So when I is 1, we have 1 squared. Then we're going to add that to 2 squared, adding that to 3 squared, and we add that to 4 squared. So each time I is replaced with the integers 1 through 4. Our next step would be to evaluate the exponent of each term and simplify through addition. So you can see 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so the sum is equal to 30. And that's an example of sigma notation. Example number 2 of sigma notation is asking us to find the sum of the expression 3j minus 7 as j increments from 6 to 11. So the first step we do is we substitute each value from 6 to 11 into the formula 3j minus 7. So the first step is to replace j with 6, which gives us 3 times 6 minus 7. In the second expression, we replace j with 7. In the third expression, we replace j with 8. Then we replace j with 9, replace j with 10, and then finally we replace j with 11. Our next step would be to simplify each expression. So 3 times 6 minus 7 gives us 11. 3 times 7 minus 7 gives us 14, and so on. And when we add everything up, we have the sum totals 111.